Hello friends, welcome back to JEE Blunders, where you learn the don'ts first. Laws of motion is definitely one of the most beautiful topics in physics, and today we're going to kickstart a series with the discussion of the topic of pseudo-force. So here's the problem we have. We have a block of mass m that is tied to the ceiling of a lift that is falling or that is accelerating down with an acceleration a that's less than g. And the problem is that we need to find the tension in the string, right? So this is the problem we have. And so as always we want to start with the free body diagram of the block that we're analyzing, and before we do that we need to fix the frame of reference, right? So in the first case, let's consider the frame of reference to be the ground. So we have the ground, and someone standing on the ground is observing this block of mass m. So what will they observe? Well, they know that the weight of the block is going to act in the downward direction, and they also know that the string is going to pull on the block upward, right? And for this person standing on the ground, this block is accelerating down with an acceleration of a, right? So by Newton's second law, the net force on the object, which is mg minus t, must equal mass times acceleration. And so according to the person on the ground, tension in the string t must equal m times g minus a, right? So this seems reasonable. But what if we were to change the frame of reference? What if someone wanted to observe the block from standing inside the lift, right? So even in this scenario, we know that the lift is accelerating with an acceleration a less than g with respect to the ground, right? But the observer is inside the lift. So what will the observer observe? The observer is still going to observe that the weight of the block acts on it, and they're still going to see a tension in the string t, right? But according to the observer now, this block is at rest because according to this observer, everything inside the lift was accelerating down at an acceleration a, whereas now according to this observer, the block is at rest. So if this observer were to write the equations of motion, or were to write Newton's second law for this block, they would think that mg minus t equals mass times the acceleration of this block in their frame of reference. So that would be 0. So this observer would feel that t equals mg, right? So, well, you might say, okay, so maybe the tension, so different observers observe things differently, and so we have different equations. But the problem is the string, we are looking at the tension T in the string, right? So that is, the string can only have one value of tension, right? So what exactly is happening here? So I encourage you to pause the video and think for a second as to why we're getting different values of tension in the string. So assuming you're back after having thought about it, this is a very, very important concept in physics, which is why we did this problem. But the observer here, who is standing on the ground, is known as an inertial frame of reference. And the observer inside the lift, who's accelerating with respect to the ground, this observer is a non-inertial frame of reference. And Newton's second law, in its original form, can only be applied when the frame of reference is inertial. For a non-inertial frame of reference, we need to apply something additional known as a pseudo force. And that, my friends, is the biggest takeaway from this video. For a non-inertial frame of reference, we need to apply an additional force known as the pseudo force, which has a magnitude of mass times the acceleration of the frame of reference in the opposite direction of the acceleration. So what I'm saying is that you need to apply an additional force which equals mass of the object times the acceleration of the frame of reference, and because the acceleration was down, we applied it upwards. And now, so what we have realized that what we did earlier was wrong, and now having applied this pseudo force, now we can use Newton's second law. So the same observer will observe this block to be at rest, and these are all the forces acting on the block. So the net force is mg minus t minus ma must be 0 according to this observer, because the block is at rest according to him. And so T would be m times g minus a, which is great. We get the same answer as before. So this makes more sense, right? The tension in the string should be independent of the frame of reference. And so hopefully you found this to be a very interesting video. And the key lesson that we learn here is that pseudo force needs to be applied in a non so the pseudo force has to be applied in a non-inertial frame, and that is the key lesson to be learned. Bye.